G'day students, we now move on to part B of our task, okay? And this starts to link what we're trying to look at to triangle numbers. So we're going to spend some time thinking about triangle numbers. We might have remembered we had a look at a pattern there, like stacks of logs, but there's a little bit on that in the PowerPoint presentation too. You can establish a new conjecture related to triangle numbers and pathways home. And there's no reason why you can say, well, that the number of blocks, for example, as you start by looking at a 1 by 2 and then 2 by 2 and 3 by 2, the number of blocks might just equal a triangle number. You start with that as a conjecture and see how it works. And then we're going to test and develop that. So let's have a quick look at what we know about triangle numbers here. We have been looking at the part A stuff. Okay. Part B, right? Does add here, I might just say, you have to evaluate and revise your conjecture. Okay, so if it doesn't work, say, okay, why hasn't it worked? How can I change it? Can I still see a pattern that works with triangular numbers? So here's the basis of triangle numbers. They form a triangle when you put the dots. It's kind of like a square cut in half. The first one has 1, 3, 6, and so on. And you can keep adding one number that's bigger each time and find your triangle number. Some people may even notice a pattern. They may have noticed a pattern similar to that in part A. But there's also an algebra rule that we can use. It's the triangle number. So the first triangle number would be 1. N equals 1. N is just the number. So you say it's 1 times 1 plus 1. 1 plus 1 is 2. So 1 times 2 is 2. 2 divided by 2, the first triangle number should be 1, and we go up to here, we say, well, n equals 1, our first term is 1. We can do it for anyone. They've got the example of n equals 4. So if n equals 4, n plus 1 has got to equal 5. So let's put it in. N times n plus 1 is 4 times 5 divided by 2. 4 times 5 divided by 2, 4 5s are 20. 20 divided by 2 is 10. So our fourth triangle number should be 10, and it is here. Now I've set this up in a spreadsheet is one way you might do it. You might think it'd be a good idea to start with those calculations. Here's the rule. Now, for some reason, there's a little dot on my screen that I can't get rid of. I suspect it's there in the corner. Just remind the rule is n times n plus 1 divided by 2. So when n equals 1, my calculation is going to be 1 times 1 plus 1. 1 times 2 is 2 divided by 2 equals 1. Now, remember in maths, we want to do the communication. So I've taken a shortcut, and I'm just doing this here. I'd be writing a few of these out. So you're showing me that you can substitute in. You're explaining the process that you're using. N equals 2. So 2 times 2 plus 1. 2 times 3 is 6 divided by 2 is 3. Okay, so we've got those triangle numbers here. Now, in our previous little example, we started to look at the number of pathways. We said with a 1 by 2 grid. Right, so if it was 2 south and 1 east, we could find 3 different pathways. 2 south and 2 east, we found 6 different pathways. So if I started with my conjecture, I said, okay, pathways is going to equal the number of triangle numbers. The number of pathways is going to equal the triangle number. So for a grid that has a 1 block south, that's going to be the same as n equals 1. So it's going to be my first triangle number. So I can start putting this into a table. Now, when I've looked at my conjecture, this doesn't actually work because when I found 3 pathways here, but my first triangular number was 1. And the second, if n equals 2, we say the number of blocks south is our triangular number. The second triangular number is 3, but I found 6 pathways. But keep going, you may find a pattern, right? So the idea is once you've done this, you can say, okay, it's probably not going to work the first time, but maybe I can make an adjustment. Maybe I can see something that will help me to work through and improve this. I just want to sneak back to the task sheet if I can, because I'm going to scroll down. I want to emphasize one thing here, okay? I want to emphasize the communication you're looking to do as you do it. You're thinking about explanations of what you're doing mathematically, including what reasons for the choices that you made. Okay, so if you don't think the conjecture works, why did you choose to test a second conjecture? What was the strategy you used to compare the two. You set up a table, you looked at that, and what are the conclusions reached? Make sure you're being clear and showing, because you want to be getting as many marks of communication as you can. So there's a little help to get started on part B.